Hello and welcome to my channel. This is my first video. This channel will be about programming, coding. I will use English language, which is not my native language, and I'm sorry about this. I'm gonna be better, but yeah, now I'm not yet. So yeah, today I'm gonna tell you about the way of realizing a dragon curve in Python using recursion. Let's start with a little demonstration how it works. So we just paint this beautiful fractal. It's really amazing. I'm really into this kind of beauty of these fractals. I love this. I love this. And it's actually pretty simple to realize, to create a code which will draw this beauty to you. It's actually pretty simple. And yeah, it continues for a very long time. So let's start. First of all, in our function, we got our little function. It's a Pythagoras theorem to find the side from hypotenuse using a square. So we got our hypotenuse. It will be L length, and we finding a square from it, square from L. We divide it by 2 because in this algorithm, in this curve, in this fractal, we are using triangles, whereas two sides is the same and hypotenuse is a little bit bigger. Yeah, so we have 90 degrees angle inside our triangle. So then we find a root from this divided square, and finding a root in Python is just powered by 0.5, and this is our root, and we will use it. I will show you right now, here and here, 2 places. First of all, in every recursion function, we must think about the deepest level of our function when our n will be equals to 0. And n, it's number of iterations we want to use. It's number of levels, how deep we want to go inside the function. And we use it first time when we call this function. So we use, it's right there, down below. It's the length and the number of how deep we want to go. So I was showing to you 12 numbers, yeah. But we will start from something very easy. Let's start from 0. Okay, so we already have, and we already starting to discuss this first part of our code. If our n is equals to 0, we're just going forward by length we have. And of course we're using, I forgot to tell you about this, we are using default turtle inside Python, so we don't need to download anything to use this. This is by default inside Python, so you can just import turtle and using this. Yeah, we're just going forward and we return, so we go to the previous level. So let me show it to you. I got something. I got this. This is the levels of how deep we go inside the function. If our n is 0, so we call our function right there, and our n is 0, right? So we just return one straight forward line. So let me show it to you. It will be fast. I will disable fastest speed, and we can see this. Yeah, that was fast. And okay, so now let's go for the rest of the code. If our n is 1, it's not 0. Let me draw this right there. So we go to the next code. What we got there? Here we just ask if our function is going to the right or going to the left. But for the first time, it actually even doesn't matter, because then we use our function again and we use it for the turn right, but we actually can disable this. We can delete this and we can delete this also. We just can go turtle right 45 degrees and that's all. Everything will be okay, because what we actually do in this algorithm, in this curve, we create triangles. So from this first line we do at 0n, we create something more interesting. We create triangle. So we find the side of this triangle like this. We find the length of this side at the beginning of our code. It's right there. So it's Pythagoras theorem. Yeah, and we found the length of the side and we draw this. But to draw this correctly, we need to turn our turtle, right? So we've turned it by 45 degrees, then we go forward. So how we go forward? Instead of just right going forward, we use our function again. So we go deep right there. And if our n is 1, so on the next level it will be 0, because we use n minus 1. We make it lesser each time by 1. In this case, all these functions is just our first part of the code, because 1 minus 1 is 0 and turtle just going forward in this case. This is how we got this line. We use the same function again, but in this case n is 0, so we just go straight forward. Then what we need to do is we need to turn left. So how we turn left? Our vector where we go is right there. So then we just move to the left by 90 degrees. Here's 90 degrees. And we go left right there. I'm showing it to you. I hope you can see this. And then we use the same function again. The same function. And in this case, it's n, it's 0. We go deeper. We subtract 1 from our n, which is already 1, so we got 0n. And again, it's just a straight line, and we go up. And then what we do is just, in this case, it doesn't matter. We already got our triangle. But if we go further, we just need to save our vector. So our vector is right here. We move right here. But we need to be at the same position as we were when we just got started, right? So we need to go to the right by 45 degrees. And we do this right here. It's very simple. And this is the end. This is the end of using 1n. This is the end. We just create this triangle and that's it. Let me erase these numbers. We already know what it is, okay? But what if we go in deeper? What happens next? So let me show it to you right there. If our n from the beginning, from the first call, will be 2, on the next level it will be 1, right? And on the next level it will be 0. And we know what happens when our n is 1, right? We know what happens, how it actually looks in here. So we made a call and we go deeper 2 times, because on this level we use function 2 times, first and second. Then we go deeper from this another 2 times, right? To third level of dive, I would say dive. Yeah, so we're on the third level, and only on this level we actually draw. And how we got on this level, let me show it to you. So first of all, first iteration, we go right there. Then we go deeper. We go inside our function, we turn to the right. Then we go another time inside our function, and it's still not 0, so we turn to the right again. How it looks right there. So we turn to the right first time, then we turn to the right another time, right? And we don't even start to draw something. It was 2 times, and only then we call the function where n is 0 and we start to moving forward. Only then we draw this. Let me change the color. Only then we draw our line. Okay, only then. What happens next? Then we go back from this level like this on the previous level, and then we go forward. Then we turn to the left for 90 degrees, right? We turn to the left, we draw this line. How we draw this? Yeah, we go another time to the third level, and then we go back right there, and then we go to the next function right here. And this is where our turn actually start to make sense. It's right there. Let me return this turn. Let me return these turns. Okay. Yeah. And now we got it. From the first call, our turn is right by default. So this means that we don't need to write it right there. So we don't need to write something like this, right or left. By default, it's right. But you should know this. We was doing every time, we was doing right turn, using right turn till this moment. Because now we got this function, right here, and we call this function with turn left. Actually, we called this function before, but it doesn't matter which turn it was, because every time this was 0, we just going forward, okay? Before, when we was drawing this red triangle, we go to the right from our line. We were. And now we need to go to the left. So we call this function with left turn. And what it means? It means that we don't turn to the right, we turn to the left, okay? So now we turn to the left, right there. We go in like this, right? Our vector is like this. And before we go into the left, our turtle moves left in this level. So when we go from this to this, right, we have this part of code and our turtle go to the left. It's actually where we turn, and this is where we turn to 90 degrees. This is where we turn, of course. And only then we turn another time for 45 degrees inside our left function. Yeah, we go left to the left by 45 degrees. And then what we do, we actually call right function. But in this case, it's just 0, right? Our n is 0 and it just moves forward, and we have this line like this. Okay, I already draw this. After this, we go to the right because our turn isn't right, okay? Our turn is left, and that means that we need to go opposite side to the right, 90 degrees again. So it looks like this. We go there, we turn to the right by 90 degrees, right? And we start to draw this line because we already have this function with 0 again, okay? And with 0, we just draw a straight line. And that's it. We got our second iteration. That's pretty simple, right? It's actually pretty simple. I take so much time to describe this. What if we go in deeper, right? You ask me, what if we go in deeper? What will happen? And nothing completely different. All the same. Last difference was in this iteration because we start using left turn, right? So I forgot to draw this. So we go like this, like this, like this, and like this. This how we go inside our function, right? So it's pretty simple. Okay, let me erase this. So what we got next? We just go deeper and deeper. But you already got the point, right? I don't need to actually draw this. And we got not 2, we got 3 here, right? And we get, I'm sorry, I can't draw this accurate. 3, 2, 1, and our n is 0 only right here. So we know what will happen, right? We just know what will happen. What we do next? We create like another level of function, right? Even before we start to go somewhere, our function going right and right and right and right again. It goes for the third time, 45 degrees to the right, okay? I will not draw degrees anymore, okay? You got the point. Then, only then, our n is 0 and function returns straight line. And we draw this. Then we go to the right there, okay? And all this happens inside third level. On fourth level, we draw the line. Then we go back, okay? Then we turn. On the deepest fourth level, we draw the line. Then we go back, go to the next function in third level, and we go to the left functions because first function we call is right, second is left, okay? We call left function and we go like this, okay? That's very simple. What happens next? You ask me, what happens next? We go to this, and what is this? Is right function. On third level, it's right function. Okay, so because we like go back on the same level. And we go to the right. We go like this. And then we go like this. Okay? And then we go to the left. This is how it works. So we go to the right from our previous line, which is green, then to the left, then to the right, then to the left. This is how it works. And let me show you another level of deepness. Okay, I will just draw this real quick. So we go like this, like this, like this, like this, like this, and then we go to the left here, then to the right here, and to the left here. You see, we got our first touch. We touched previous point right there. And that's what we got. Yeah, that's a mess already. And this is how it works. It's pretty simple, right? We go deeper like this, 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 and deeper, 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 deeper. So much deeper. And what we got on fifth level? Look at this. Oh, it goes too far to the right. I need to call from smaller length. Okay. And let's try something like 10. Here we go. And we can use turtle fastest speed to create something really, really interesting and really fast. That's beautiful. That's beautiful. I can just look at this for a very long time. That's the beauty of programming. Yeah. Okay, but anyway, that's it for this video for today. Thank you for watching. I'm sorry about my language. I will get better. Yeah, sorry if it was too long for you. It's actually pretty simple. And see you in the next videos. Don't forget to subscribe, leave a like, leave a comment, and you know. Okay, see ya.